Here is the key to your review. As always, the numbering doesn't make any sense. Just ignore it, get over it. So I've got to solve these inequalities. I'm going to do this with a sign chart on my number line. So the first thing I need to do is factor. So I'm going to factor this by grouping. Get x squared times 2x plus 5. Then I can factor out a negative 16, and that leaves me with 2x plus 5. That is greater than 0. So then I get x squared minus 16 times 2x plus 5 is greater than 0. So x plus 4 times x minus 4 times 2x plus 5 is greater than 0. My zeros then would be plus or minus 4 and negative 5 halves. So I need to put those on a number line. So I would have negative 4, negative 5 halves, and 4. So this is the one I'm going to substitute things back in. If I use a negative 5, that would give me a negative, 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 which makes that negative overall. Between these two, if I put in a negative 3, that would give me positive, negative, negative. That's positive overall. Between negative 5 halves and 4, I can put in 0, so that's positive, negative, positive, negative overall. Then I can put in 5, that would give me positive, positive, positive. Okay, I didn't put my points on my number line originally, so this is just greater than, not greater than or equal to, so these are all open. Then this is negative, positive, negative. I can do that, positive. Okay. And I need this to be greater than 0, so that's my positives. This is positive between negative 4 and negative 5 halves. And these are both open because it's not included. Then I union that with 4 to infinity. This is me solving the inequality. This is my sign chart on my number line. All right, so let's do a couple of rationals. So it's already set equal to 0. I just need to factor. So my numerator would give me x plus 4 times x minus 3 over x minus 1 greater than 0. So my zeros are negative 4 and 3. My vertical asymptote is at x equals 1. So all of that goes on my number line. So I have my negative 4, 1, and 3. The vertical asymptotes always get open circles, and then my zeros are going to get open circles because that's not included there, so everything's open. When I've substituted a negative 5 here, I'll get negative, 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 so that's negative overall. I can substitute in 0 here, so that'll give me positive, negative, negative. I can substitute in 2, that'll give me positive, negative, positive. That's negative. And then I can substitute in a 4, that'll give me positive, positive, positive. Okay, so negative, positive, negative, positive. And I want this to be greater than 0, so again, I'm looking for my positives. It's positive between 4 and 1. Those are open. And then it's positive again from 3 to infinity. Oh, negative 4, not 4. Negative 4. All right, 42. It is not set equal to 0, so I need to do that. So this will give me 7 over x plus 3 minus 6 over x plus 2 less than or equal to 0. I need to get a common denominator. So my common denominator is going to be x plus 3 times x plus 2. So this will give me 7 times x plus 2 minus 6 times x plus 3 less than or equal to 0. I'm going to move my work up here. My denominator is still x plus 3 times x plus 2. The numerator would give me 7x plus 14 minus 6x minus 18 less than or equal to 0. Then 7x minus 6x is x minus 4 over x plus 3 times x plus 2 less than or equal to 0. So this is what I use to figure all the rest out. My zeros is just just positive 4. My vertical asymptotes, I got x equals negative 3, x equals negative 2. So all that goes on my number line. So we'll have negative 3, negative 2, and 4. So this is less than or equal to, so my 0 here, it has a closed circle, but the asymptotes always have open circles. Substitute in a negative 4 into here, I'll get negative, negative, negative. It's negative overall. So a negative 2.5 will give me negative, positive, negative. It's positive overall. 0 will give me negative, positive, positive. 5 would give me positive, positive, positive. Okay, so negative, positive, negative, positive. And I want this to be less than or equal to 0, so I'm looking for where it's negative. It's negative from negative infinity to negative 3. You never include your infinities. Negative 3 is open. Then we start back over at negative 2, and it's negative until we get to 4. Negative 2 is open because it's an asymptote. 4 is closed because it's a 0. That's my answer. Okay, sketching a graph of polynomial with the sign chart. So really I can do it on the sign chart too. I know this is positive. I hit this, it's positive again, so there has to be a bounce, right? And then it comes down here and it's negative, and then it's positive again. It'll look something like that. So I've just got to get my numbers on here. Let's see, this is at 3 and negative 3, so I can go 1, 2, 3, 4, 1, 2, 3, 4. Then I have, so I'm here at negative 3. That's where my bounce is. And then 1 and 3. So my graph comes down here, it bounces, comes back up, goes down and it's negative, and then comes back up and it's positive. I don't know how positive or negative it gets, and I don't know where my y-intercept is, but I can at least get that done. Okay, so now we're going to find all the zeros and give the complete factorization of the function. So to find the zeros, I'm going to factor what I can. So 0 equals, so give me x squared and x squared. This is negative, so the signs are opposite. I need two numbers that are going to multiply to give me negative 72 and subtract to give me 14. So that's a positive 18 and a negative 4. So then that gives me x squared plus 18 times x plus 2 times x minus 2. Then I'm going to find my zeros. So x equals 2, x equals negative 2, x equals plus or minus the square root of negative 18. So that negative 18 tells me I know there's going to be an I that comes out. Plus, when I have to simplify the square root of 18, so equals, plus or minus, it's going to be 3i times the square root of 2. So it said to find all the zeros and then can give the complete factorization. So my zeros are plus or minus 3i square root of 2 and plus or minus 2. There are my zeros. My complete factorization is x plus 3i squared root of 2 times x minus 3i squared root of 2 times x plus 2 times x minus 2. Those are the two pieces I was asked for. Okay, so then do the same thing here. So I'm going to factor by grouping. Can factor out an x squared. That leaves me with 3x plus 1. Then I can factor out a negative 12. That leaves me with 3x plus 1. 0 equals x squared minus 12 times 3x plus 1. Then I can find my zeros. X equals negative 1/3. X equals plus or minus the square root of 12. So that means x equals plus or minus 2 square roots of 3. So then my zeros are plus or minus 2 square roots of 3 and negative 1/3. My complete factorization is x plus 2 square roots of 3 times x minus 2 square roots of 3 times 3x plus 1. All right, on the back. So now that we have been given zeros, we need to write a polynomial function. So f of x is going to equal the a value that we don't know yet. If I have a 0 that's 1, that means I have a factor that's x minus 1. This has a multiplicity of 2, so that's squared. Then if my 0 is 4/3, that means I get 3x minus 4. So I have my y-intercept. I'm going to use that to find a. So negative 8 equals a times negative 1 squared times negative 4. So negative 8 equals a times, well, negative 1 squared is positive 1, so this is a negative 4. So that means a equals 2. So then my function is going to be 2 times x minus 1 squared times 3x minus 4. All right, 16. Start off the same way. F of x equals a times, so I have a plus or minus 3, so I get x plus 3 times x minus 3 times x plus 2 square roots of 2 times x minus 2 square roots of 2. My y-intercept is a negative 72, so that's equal to a times 3 times negative 3 times 2 square root of 2 times negative 2 square root of 2. So negative 72 equals a times negative 9. 2 square root of 2 times 2 square root of 2 is 8, so that'd be a negative 8. So this will give me a positive 72, so when I divide, a is negative 1. So f of x equals negative x plus 3 times x minus 3 times x plus 2 square roots of 2 times, x minus 2 square roots of 2. And there you go. Okay, so in this bottom section, or these bottom sections rather, there's a little place for work, which may not be enough work, but I'll make sure on the test you have plenty of work. But you may need to factor and stuff like that, which we do. So when I factor this one, this will give me x minus 3 times x plus 2 over x plus 2. So the first thing we're looking for is our domain. So our domain, the only thing that affects our domain are vertical asymptotes and holes. Here I have a hole. This cancels out, so the x value for the hole is at a negative 2. And that means my domain is the set of all x's such that x cannot equal negative 2. Right? And then, so my reduced function is just x minus 3. Substitute the negative 2 in there, you get negative 2, negative 5. There is not a denominator, so there are no vertical asymptotes. This next one, I don't need to do any work because I don't need to factor. There's nothing to factor, and it doesn't simplify, so there's no work there. I don't have any holes, I know that, but I do have a vertical asymptote at x equals -5, and that's what affects my domain. So my domain is a set of all x's such that x cannot equal -5. Right. This next one I need to factor. This gives me x plus 4 times x minus 4 over x times x minus 4. So my domain, set of all x's such that x cannot equal, well, I'm going to have a hole here with an x value of 4, and then I have this 0 for a vertical asymptote, so it can't equal 0 or 4. Like I said, so I'm left with x plus 4 over x. So when I substitute this 4 in here, that gives me 8 over 4, which is 2. And my vertical asymptote is at x equals 0. Okay, so I need to factor this one. This is a difference of cubes, something you have to know how to factor. So I'm going to have a binomial and a trinomial. So I take the cube root of that, that's x. Cube root of 8 is 2. My signs are same, opposite, always positive. So this is x squared plus 2x plus 4 all over 3 times x minus 2. So once again, I'm going to have a hole with an x value of 2. My reduced function is x squared plus 2x plus 4. That's all over 3. If I substitute my 2 in there, that's going to give me 4, 4, and 4, so that's 12 over 3, which is just 4. So my domain, set of all x's such that x cannot equal 2. Vertical asymptotes, I have none. Right. So now let's look at the horizontal and oblique asymptotes. So I could factor these, but I don't think I need to because I can look at this and I just have to decide for horizontal asymptote if it's top heavy, bottom heavy, or tied in degree. These are tied in degree, so my horizontal asymptote is just y equals 3/4. If I have a horizontal asymptote, I can't have a slant asymptote, so I really don't have any work to do there. When I look at this next one, it is top heavy, and it's top heavy by just 1. Top heavy means no horizontal asymptote. Top heavy by 1 means it will have a slant asymptote. And I got to figure that out by division. Okay, so since I didn't use this workspace up here, I'm going to kind of use both of these places since I didn't give you very much room. I'm going to have x squared plus 2 gets divided into x cubed plus 2x squared plus 0x minus 5. Don't forget your placeholders. So x squared goes into x cubed x times, gives me x cubed plus 2x. And so then I change the signs and, oops, I put that in the wrong spot. Look at me. Put the placeholder there and then I didn't use it. Okay, x cubed plus 2x, but the plus 2x has to go over here. Change my signs, so those zero out, and I get this 2x squared down here, and then minus 2x. So the x squared goes into 2x squared, a positive 2 times. And because I'm not having to actually divide this whole thing out, I can stop when I get my linear, and then this is just x plus 2, because I don't care about the remainder. All right, this next one. This is bottom heavy. Bottom has the 2 O's in it, so bottom heavy means we have a horizontal asymptote at y equals 0, which means there's no slant asymptote. This next one, these are tied in degrees, so again, it's just the ratio of the leading coefficients. So it's y equals 4, and this is none. Next one is top heavy, so there is no horizontal asymptote, but it's top heavy by 1, so there's a slant asymptote. I can use synthetic division on this, so I'm going to have -5 divides into 4, -1, 2. Bring down the 4, that's -20, -21. Oh, negative 21. Then once I get that, the rest really doesn't matter. This is just y equals 4x minus 21. On this last set, we're going to omit the very last one because it doesn't factor. So we can still do it. We just have to use quadratic formula, and we don't need to do all that. Okay, so to find my zeros, I do need to factor. So I'm going to factor this, and I'm going to get x minus 5 times x plus 1 over x minus 5 times x minus 2. So remember, we find our zeros after reducing. I can reduce this. So I have a hole when x equals 5. There's nowhere for me to write that, but I know that that's where my point discontinuity is. My reduced function is this. This is where I get my zeros from, so this is just negative 1. My y-intercept is when x is 0, so this will just give me 0, negative 1/2. Need to factor this one. This will give me x minus 3 times x plus 2 over x plus 3. So there's no holes here. I have 2 zeros. That's negative 2 and 3. I have a vertical asymptote here also, but again, it didn't ask me for that. Y-intercept, substitute in 0 for x, so I'll have negative 3 times 2 over 3. So it's 0, negative 2. All right, so there is your review. I would suggest you also look back over maybe some of your other Delta math assignments and your notes.